And good day, geometry. We're starting our last algebra unit, which is on square roots. We just spent a unit on exponents, so it only seems fitting that our next unit would be on radicals. So stuff we've done with radicals before. We started, which you didn't have me for pre-algebra, but in 6th grade probably, you looked at evaluating them, right? And the word evaluate means to like find the answer, right? Find the value of. And so what's the value of the root of 36? 6, right? What's the value of the root of 121? 11, okay? We like these because they're perfect squares. Is kind of you're introduced to square roots by just evaluating them, okay? Then last year in algebra, we went to estimating them. And as you know, estimating means get an approximate value, okay? We can't actually evaluate the root of 19 because it's an irrational number. If you take the root of 19 in a calculator, you get a nice, long, nasty decimal. It doesn't work out, right? There's no number times itself that gives you 19. So explain to me how we would estimate this. Caleb.
Times the square roots on each side, so it'd be 25 and 16, so it'd be 4 and 5.
Good. Yeah. Okay. We look for those perfect squares that are on either side of it, so at least get a range here, right? Root of 19, because it's between root 16 and root 25, is going to be between 4 and 5. So what number would you estimate, decimal nearest tenth, what number would you estimate root of 19 to be? Peter? 4.3, 4.2, 4.4, somewhere around there. How about root of 200? What would you estimate the root of 200 to be? Blake? It's less than 15. Gino? More like 14 point probably 2, because root 196 is 14. So it's really, really close to 14, so probably 14.2. How about 44? What would you estimate that to be? Drew? 6.7, sure. It's pretty close to the root of 49, which is 7 exactly, right? So a little bit less, so about 6.7, okay? What we're going to do today, and really what this whole unit is going to focus on, Michael, is simplifying square roots. And what does it mean to simplify something? Evaluate means to find the value. Estimate means to get an approximate value. What does it mean to simplify, Caleb? To make it more simple. Okay, well, yeah, I mean, okay. Does the value of a simplified expression change from the original value? Anybody? When you simplify something, does the value change? No. When you simplify the fraction, 30 35ths to 6 sevenths, the value is the same, right? We just took out any common factors or whatever. So who can remember back to last year, since we've apparently done this before, how would we simplify the root of 45? Few hands in the air. Will? Yeah, very good. Okay. Why would we take the square root of 9 and the square root of 5? What's significant about those two roots, or at least one of them anyway? They multiply to 45, right? That's important. Mackie? The root of 9 is a perfect square, right? We could also say that root 3 times root 15 multiply to be root 45, but that's not going to do us any good because we can't really do anything with 3 or 15. Okay? With 9 and 5, we've got that perfect square, which means we can evaluate the root of 9 to be 3. And even though we can't do anything with the root of 5, that doesn't matter. Just kind of tacks on there. Okay? And so the simplified value of root 45 would be 3 times the root of 5, or 3 root 5. Light bulb starting to pop on for anybody else last year? No? Okay. Well, that's why we're covering it. Okay?
It's a damp light bulb.
Dim. Yeah. Flickering. Dim and flickering. Okay. Looking at the root of 20. We need two numbers that multiply to make 20. That's a requirement, right? So we can either use the root of 2 and the root of 10, or the root of 4 and the root of 5. Right? Those are the factors of a 20. Which pair are we going to be using here? James? 4 and 5. We want the one that has that perfect square. Okay? So root 4 times root 5. The reason why we want that perfect square is because now we can evaluate that. We can break it down. The root of 4 equals 2. And then we have the root 5. Okay? If you were to take the root of 20 in a calculator and then take 2 times root 5, you will get the exact same thing, about 4.5 or so. Okay? We're not changing the value of this at all. We're simplifying. Okay? How about root 700? What do you think for that one? Gino? Okay? 107. What does that simplify down to be? Gino? 10 root 7. Good. Good. How about root 72? 2 factors of 72. Peter?
Root 36 and root 2.
Oh, Peter, you stole my thunder. 36 and 2. Who was thinking 9 and 8? Was anyone? Okay. I'm going to start with that one, just because with simplifying roots, there's something you have to be careful of. Okay? Root 9 times root 8 will work here, right? Because 9 is a perfect square. We can simplify that to be 3, and then we have the root 8. However, why are we not done yet? Why are we not done yet? Doing this would be like taking 16 twentieths and simplifying it to be 8 tenths. Right? Which is right. I mean, but it's not in simplest form. Why is 3 root 8 not in simplest form here, Peter?
You can still simplify root 8.
Because you can go further with that root 8. The root 8 can be written as the root 4 times the root of 2. Right? Which that root 4 becomes what? Evaluates to be 2. And so ultimately we get 3 times 2 times root 2, or 6 root 2. Whereas Peter, being the efficient man that Peter is, picks 36 times root 2, and what's the root of 36? 6. We get to the final answer in 1 step rather than 2 steps. Okay? So, how do you know, what's your kind of, how can you be sure that you're simplifying it completely in 1 step? What are you looking for? Caleb?
I actually had a question.
Save it for now. Blake, what are you looking for? A big number. Okay. Gino? Not necessarily an even number. Try again, Blake. No? I mean, 9 and 36 are both perfect squares, but 36 is bigger, right? If you break it down into the largest perfect square first, you won't have to simplify a second time. Like that 16 twentieths that we just had up here. If I divide both by 2, I get 8 tenths. You know, people in the last class asked why I write so messy. It's because I know that when I turn my back to write on the board, chaos happens. So I have to get what I have to write up here as quickly as possible and turn around again so I don't get, Tweedledee and Tweedledum. Okay? So if I could trust you all when I turn my back to write something on the board, my handwriting would be much neater, right? I'm glad we have this on recording so that conference time I just play this back. Say, this is what's going on in geometry class. Here's the audio proof. Okay. Anyway, so 16 twentieths, yeah, if we divide by 2 and divide by 2, you get 8/10. That requires us to divide by 2 and divide by 2 a second time, right? We didn't simplify by the greatest common factor, which is why we had to do it a second time. Same kind of thing here. If you don't pick the greatest perfect square first, you'll have to do it again. You have to simplify further. Just watch out for that. Be looking for your root. When you get to an answer, look at your root and say, can I simplify further? Can I simplify further? Okay. Let's talk about fractions for a little bit. Any questions on this, first of all? Caleb?
Did you run out of questions? Because there's one question that we have twice.
Really? Which one?
363.
Oh, wow. You're right. Yeah. No, I didn't. I added a row, actually, and I guess I didn't even think to. Yeah, sorry about that. I'll fix it for next year's class. Okay.
Yeah, we're not going to be.
All right. 3, 2, 1. You are quiet. Who can remind me how we handle fractions? Who remembers all the way back to fractions? Sydney? Yeah, the nice thing about fractions, it seems like simplifying these roots would be a lot more complicated because fractions usually make everything more complicated. But remember, you can write this as the root of the numerator over the root of the denominator and treat them separately. Okay? The root of 27/16 is equal to the root of 27 over the root of 16. Why that's advantageous, especially with these 4 fractions I've given you to start with, what are you noticing about all the denominators? 16, 121, 25, 64, Peter? They're all perfect squares. Spirit of Christmas, you're welcome. Okay? So your denominator is pretty much taken care of once you take the root of that. Root of 16 equals 4. And how would we simplify the root of 27? Drew, Mackie, stop. Well, you're turning around, so I assume something's going on there. How would we simplify the root of 27?
You would kind of do the same as the top. So you do for 27, the factors would be 9 squared times 3 squared.
Yep. Well, root 9 times root 3, not 9 squared. So root 9 and root 3 for 27, which gives us a final numerator of what? What does root 9 times root 3 break down to be? 3 root 3. So our answer here would be 3 root 3. I'll write that up here. That was kind of 3 root 3 over 4. Okay? 3 root 3 over 4. Same thing with root 50 1/21. We would start by breaking this down into the root of the numerator over the root of the denominator. Root 50 over root 121. Again, your denominator is kind of taken care of. It's a perfect square, so it works out evenly. You evaluate that, and then you can simplify the root of 50. Okay? Questions on this? Okay. Your homework for tomorrow is to do just this first page. You'll likely get your test back tomorrow. If not tomorrow, then on Friday. But so we'll take a break. Maybe we'll cover this tomorrow. I don't know. Anyway, homework tomorrow. Finish the page. Simplifying square roots. That's high math.
Don't forget to like